This is a quarter-scale model of Swift.
Okay.
And it has 3 telescopes on board. This funny-shaped one is the BAT. That's the Burst Alert Telescope, and that's the Gamma-ray detecting instrument. And then we have these 2. This is the X-ray telescope, the XRT, and around here, the UV-OT, the UV optical telescope. So the BAT can see about 1/6 of the sky at any one time. So it detects an increase in gamma rays and works out that, yes, it is a new source. It's not something that we've seen before. And it will send the commands to the spacecraft to slew round to point these 2 in the right direction because they have a much narrower field of view. It usually takes between about 1 and 2 minutes to get into position, which is where the name Swift came from.
So it's important to get there very quickly.
Absolutely, yeah. Without the information in the first couple of 100 seconds, we would miss out so much of the science.
So while all of this is going on, when do you lot find out about it?
So when the BAT detects a new gamma-ray burst, we get text alerts to our mobile phone. So we usually know within seconds that there has been a new gamma-ray burst. We get on the telecom, we discuss it. It's been automated enough that not a huge number of people actually have to dial into the telecom anymore, and it is noticeable that overnight people don't tend to. I do, because I'm nosy. If we're on call, any burst that goes off, I will dial into the telecom. It's just the thrill of knowing that I'm one of the first people to have seen these data. It's just really exciting.
So you were on duty earlier this week.
We were, yes. So the duty roster switches between the US, the UK and Italy, specifically for the X-ray telescope side of things. And yeah, we were on duty. We actually had 3 bursts go off during our duty week, which was pretty cool.
So how often do these things happen?
We believe that gamma-ray bursts go off in the universe probably about once a day, but Swift doesn't detect all of those. So on average, Swift detects about 90 bursts a year. Just under 2 a week on average, but we've had 5 in a 24-hour period before, and that was fun.
But that number's extraordinary, 90 a year.
Yeah.
And you think it's 1 a day in the universe. So we're capturing 1/4 of all the gamma-ray bursts that happen in the universe.
Swift is, yes. Before Swift, there weren't any telescopes that could do this on their own without human intervention, so it would be hours before they could follow up. Swift has completely revolutionised the field of gamma-ray bursts in the 10.5, almost 11 years since it was launched.
So how many have you found in those 11 years?
As of today, 977.
OK, well, we need the 1,000th one to be exciting.
Yes, we're counting down to that. We reckon it should be 1,000 before the end of this year.
Well, here's to number 1,000. Good luck.
Thank you.